becoming redundant, right? That's an idea. We don't want to make a product that is redundant. We want to ensure that basically the functions of that product will continue. Another thing is about rethink. Rethinking is really about disrupting the status quo of thinking about take, make, and dispose of. Rethink, make products that basically use more that can be used more intensively, that can be shared, that can be recalled. So think about that things that can be redesigned, but using the same material. So the thinking aspect is an important part of circularity. Another which is part of the 9 Re's of circularity, is about reduce. What are we trying to reduce here? We're trying to basically reduce cost, increase efficiency, reduce basically waste. That's what we're trying to reduce. Reuse, which is a very important element in here about circularity, and that is, we reuse everything that is disposed of. And what do we reuse? Repair. Repair is another important thing. And repair, I mean, the EU is going to be passing rules and regulations, at least to best of my understanding, when we read the literature about the right to repair. I mean, if you say, for example, you have a phone, it goes, if it goes faulty, sometimes you throw it away. If you have a computer, if it goes faulty, you throw it away. If there is the TV set that part of it goes faulty, you throw it away. Fridges, ovens, and washing machines. Now, the idea now is to start thinking about the right to repair. Why don't we repair? We used to repair. I mean, in the good old days, our grandparents and parents used to repair. Now, it does seem that repairing is costing a little bit more in some areas. So we need to think about this concept of repairing. We need to think about refurbishing, restore an old product. Can we do that? Is it feasible? Can we be economically viable to do that? Another re is remanufacture, which we know what it is, repurposing things, and that is use discarded products or its parts in a new product with a different function, and recycle and then recover. All of these re's, again, if I may repeat them: refuse, rethink, reduce, reuse, repair, refurbish, remanufacture, repurpose, recycle, and recover are part of a circular economy. Why am I mentioning these things? All of these things potentially will need data. All of these things will require information. And all of these things will require basically a well-structured business model, that can deal with it, especially when we expand that on a large scale. And I would like to emphasize one thing here. I mean, all of these R's of circularity, basically the R's of circularity, I mean, they do, when we think about them, they do require some elements of technology for them to be applied, especially, and that's a key point here, especially that we are applying them on a large scale, especially if we have a company that is transforming, especially if we have countries that are they're pushing towards that. So in essence, when we think about these basically R's in terms of circularity, yes, I mean, we need technology, we need data. And the important element that I would like to emphasize here is that different industry might use some of these R's differently. So you can say, for example, certain industry recycling is more economically viable than reusing. Recycling is probably better than remanufacturing. Sharing or intensifying the use of the asset is better for this industry, for that industry. So we can't have what we call a one-size-fits-all type of a solution. But one of the things that you need to think about, for your own organization is that which of these elements, which of these vocabularies we can and we are able to introduce in our organization. Are we reusing, closing the loop, recycling, open, closed loop, intensifying, slowing the process, dematerializing? Which of the ones will be appropriate? Do not expect that you're going to apply everything at the same time. And do not expect that, I do not personally expect that everything is going to be, you know, all of these things in order to be able to really say that, oh, we have to apply every part of circularity. No, we can't do that. It's not feasible basically to do that. But however, one of the things that we would like to say here is that we need to understand our business models or whatever we want to apply. But one of the key elements, as I mentioned earlier, is really the issue relating to data, the issue relating to basically intelligent assets. So what I would like to talk about now is the Internet of Things and business models. The Internet of Things is an intelligent asset. The Internet of Things can be seen as a potential enabler to achieving circularity. So the Internet of Things is an intelligent asset, and it can be seen as an enabler to achieving circularity. So in order to successfully analyze and adopt a circular economy business model, we need to identify the role of this intelligent asset in the value chain of a business, in the value chain of the organization. And when you think about the role of these intelligent assets in the value chain of the organizations, you can say, for example, and repeating what could be the value chain. The value chain is obviously, as I said, you extract resources, there's an inbound logistics, operations, manufacturing, outbound logistics, distribution, consumers. I mean, the Internet of Things can apply across the value chain. You can have the Internet of Things relating to sourcing material. You can have the Internet of Things relating to inbound logistics. You can have the Internet of Things relating to basically the idea relating to operations, to manufacturing, outbound logistics, everywhere. So one of the key enablers to implement an efficient working circular economy model, business model, is really to employ the kind of technology that we have at hand. And the type of technology that we have at hand here is you know, one of it is basically the Internet of Things. So what is this Internet of Things? What can we say about it? And how can the Internet of Things facilitate, enable circularity so that ultimately we can enable our sustainability objectives? The Internet of Things is a system and an infrastructure of interdependent and interrelated, and correlated machines and devices, right? So what we have here is that we have an infrastructure of independent, interrelated, and correlated machines and devices. What do these devices do? They have the ability and capacity, that's the idea. They have the ability and capacity to communicate information and data over the internet. Why do we need this data? Why do we need the information? We need data about the state of the machine. We need data about the efficiency of the machine. We need data about the consumption of a machine. We need data about what is going wrong with this specific machine. So we could need data about almost any, you know, many things that are out there. We need data about anything in there. Once we have the data so that we can literally act upon, you know, act on what needs to be done and what needs to be implemented in there. So again, the Internet of Things is about the existence of an infrastructure of interdependent and interconnected machines and devices. Now, this has to go as part of, you know, when you're thinking, you remember in the last webinar, we talked about the circular business model innovation. And when you think about the circular business model innovation, you know, about starting up, transformation, diversification, and acquisition, you know what? We need data about all of these things. We need data when we are starting up. We need data when we're transforming. We need data when we're diversifying. I mean, if you think about transforming from one business model to another business model, that might require, say, for example, I'm moving from a traditional business model to a circular business model. How can you get the two business models to talk to each other? How can you get the two business models to understand each other without creating any major disruption to the system? And to a large extent, information data, where we have communication, would help. Diversification, and so on and so forth. In addition to that, in the last webinar, I also talked about, we have a different circular business model relating to closing the loop, relating to slowing down the consumption of, or the usage or the utilization of assets or machines or material. It is about, in addition to that, when not only about slowing down, but it is also about the intensification of the use. And then we have about dematerializing. All of these elements require some kind of data, some kind of devices, some kind of machines that will read basically indicators, that will read signals, that will read whatever is being emitted by these devices, so that we can act. You see, there are so many different components right now. There's so many different machines right now that we use. And as a result, can we, as individuals, look at all of these machines and identify what is going wrong with this one, that's going on with this one? Can we reuse, repurpose? No, there is an issue. There is an issue with that, not because we can't, but because we need to consolidate a lot of the data. We need to consolidate a lot of the information that we have in general. So, according to an Ellen MacArthur Foundation report, which is a very interesting report, and it is about intelligent assets and so on, and that is basically about unlocking the circular economy potential. The report was written in 2016. And the argument here, or the discussion, was that it was predicted that by 2020, that's 2 years ago now, that we would have 50 billion connected devices. Now we're 2022. In my opinion, we have more than 50 billion connected devices now. Why? I mean, the fact that we had this COVID situation, a lot of companies, a lot of organizations, they've digitized. There has been a transformation, a digital transformation. And digital transformation requires having these devices. So there is this digitization that was going on. And as we all know, digitization is part of the fourth industrial revolution, because it leads to the acceleration of an economic model that will replace a linear economy in a way. So what this basically report emphasized on, it was a very well written report. I think it's a fantastic report to read. Literally is that as we transition towards a society in which value creation is increasing, we will be using more devices, and these devices will be more connected. And this connection basically will allow for the transfer of data and information. So the Internet of Things would be one of the key elements, the key structures that will extract these, basically this information. So what is an IoT system? Now, if I'm going to be thinking specifically about an IoT system, what is an IoT system? An IoT system literally is about a system which depends on embedded sensors, right? Embedded sensors in all devices and equipments. So there are sensors. So one of the starting point when we think about the IT system, the IoT system, we need to think about sensors, location, and communication, right? Any IoT system requires sensors, location of these sensors, and then communication. So the IoT system depends on embedded sensors in all devices and equipment. IoT, the Internet of Things, really about having embedded sensors in all devices and equipment. This could be a mobile phone. This could be an electrical device. This could be a vehicle. This could be barcode, scanners, anything that is used on a daily basis. It will be relevant to it. Anything that we use on a daily basis. Mobile phones, electrical devices, vehicles, barcodes, scanners, anything that we use on a daily basis. What do these sensors do? These sensors tend to emit data. About what? Well, about the current functioning and working state of the device or the machine. Well, why is that important? Well, if we know the current state of the device, we can probably use it for more. We can intensify its usage. We can share it. We can prolong the utilization. We can intensify it. But if this is one aspect. But if the data is showing that these devices are not doing well, then we say, okay, it needs repair. But what do we repair? Again, what I did earlier is just, okay, if you get some kind of data and information about a device, about something, so what we don't have, what can we do this way? It's in a good working order, so we can intensify its usage. But if we are getting the data that shows that this device is not functioning well, for whatever reason, then we might say, well, can we repair it? No, it's going to be very costly. Well, can we reuse some of the material? Yeah, but we need to dismantle it. Can we repurpose it? So we need to identify which of the circular economy model would be applicable to this specific device that basically we're thinking about. So we start with sensors. Sensors will emit data. The data has to, of course, if you don't use the data, you're wasting it. And if you're wasting it, this is not circular. So if we have the data and we want to use this data, the data is shared over a common platform or infrastructure. The data is shared over a common platform or infrastructure that uses a common language for these devices, right? So the data is in a way will be shared, will be communicated. Fine. We have sensors, we have data, and we have a platform. Once the data is sent to a cloud platform, the data is then analyzed. So you want to collect the data, store the data, analyze the data, and then act. Once the data, what does it mean to say act? It means that what kind of a circular economy business model we're going to achieve. Remember what I just said as an example. Are we going to repair a machine? Well, the data is going to tell us and will give us, basically will help us make the decision. Are we intensifying the usage of this asset? The data can help us with that. Are we repairing it? Are we remanufacturing? The data will help us. So in a general economic system now, so we go beyond just what we have in an office or in a kitchen or we go beyond that and say, well, okay, if we have a general economic system with billions of devices, then there is a lot of data and there are a lot of devices and there's a lot of basically equipment that we can use. I'm sure you know that if you get 50,000 mobile phones, 50,000 mobile phones, just to give it a little example, if you have 50,000 mobile phones, you put them together, used mobile phones, I'm talking about used already, they're an older version. You can, according to some estimates, you can get a 1 kilogram of gold from 50,000 mobile phones. 1 kilogram of gold. All of these mobile phones, they have, obviously, because of connectivity, because of conductivity, because of the efficiency for the working of these devices, there are some precious metals in there, such as gold, such as silver, whatever, platinum, whatever the case might be. So if you get 50,000 of these, you can get one, I'm talking about phones now. You can get 1 kilogram of gold. But the world is full of e-waste, electronic waste. And electronic waste is not only about mobile phones. Electronic waste is about, laptops, iPads, TV sets, and so on and so forth. And all of these machines and all of these devices have some precious material within them, even on a small scale. But the addition of all of these devices literally will produce a good amount, and especially if we're thinking about a country now, especially we're thinking about the region now, especially when we're thinking about the world, there is the opportunity to extract a lot of materials out of small devices that we have. I mean, if we think about the TV sets in Europe, according to some estimates, about 60% of the TV sets that are thrown away have been thrown away over the years were in good working order. So they were working, but we've thrown them away. Why? Because you want a flat screen, because we want basically a bigger screen, because we want which is fine, it is fine, but it is not the issue here. The issue is that what do you do with these old ones? Why do we throw them away? Why do they go to landfills? And that's what we're trying to achieve here. Can we create profit out of these things that have been thrown away? Can we deal with them? And that is the idea that we want to do. Now, the Internet of Things can help us literally with all of the things that I've just mentioned, hopefully. As I'm not a scientist, but at least based on what I'm hearing from scientists, is that the Internet of Things can really systemize the way we introduce a circular economy. And specifically based on data. That's the idea, specifically based on data. So you can try to systemize as much as possible this whole idea in general. Now, adopting the Internet of Things, the adoption of an Internet of Things technology to facilitate the working of a circular economy is crucial to its implementation. And what I would like to say here is that organizations in different sectors across the value chain need to connect basically the different elements of their value chain with regards to the assets, with regards to the machines, with regards to the gadgets that they have, devices, in order to capitalize on what can be, reused, repaired, remanufactured. So technology here becomes a very critical player in the direct implementation of a circular economy model. Why? Because we want to apply that on a larger scale. On a larger scale. When we think about smart cities, no city is going to be smart if it is not circular now. When we think about smart cars or vehicles, when we think about smart buses, so all of these things require that we deal with an enabler to the smartness in the city, to the smartness in the vehicle. And remember, being smart as a city or a vehicle requires that we go circular as well. So we do need a language that is specific for this basically kind of business model. And we need a structure and an infrastructure that is specific for this business model. So the language, the structure, the infrastructure that is specific to this business model is the Internet of Things. One of it is the Internet of Things. So let's look at this, for example, here. And what do we see in front of us? Well, our objective is to try and eliminate waste, right? So when we're thinking about it, our objective is about eliminating waste. We want to eliminate wasted resources. We want to eliminate wasted capacity. We want to eliminate wasted life cycles, wasted embedded value. So we want to avoid that. We want to eliminate that in a circular economy. So in order to achieve that, the circular economy will hopefully, as a model, as a theoretical, operational, and practical model, should be designed to eliminate waste. But we need to be able to understand, how can the business model that we choose, just like what I said earlier, when we have a business model, whether it's about closing the loop, it's about intensification, it's about slowing, it's about dematerializing. So then how do we apply this business model on the kind of technology that is required to facilitate these business models? One of the key business models to reduce waste is a circular supply chain. A circular supply chain would be great but everybody in the supply chain has to buy into it. Recovery recycling is a business model. Product life extension is a business model, is a circular business model. Sharing platform is a circular business model. Product as a service, circular business model. So if we take all of these business models and we apply them on technologies, what kind of technologies will help us with all of these business models? 3D printing is a technology. Big data analytic. I've been talking about data. Collect data, whether it's from devices, from equipments, from machines, from cars, from cities. About what? Data about what? We're not talking about now personal data. No, we're talking about data that relates to devices, even the most basic data relating to cars, relating to repair. That's what we're looking at, because we don't need to complicate things in this respect. We just need to try to simplify things and keep things as simple as possible if we can, because if we keep them simple, they'll be less costly. But we need to move in that direction. So technologies like big data analytics would be important. Life and mineral sciences, trace and return, modular design, machine-to-machine communication. So a key technology to enable the different business models that we've taught is machine-to-machine, basically communication, which will be applied on the capabilities. So literally what you will see is that these capabilities, you will know that they will help us in some kind of circular networks, in circular supplies, design for many lifestyle users, continuous customer engagement, opportunity driven, all of these things becomes capabilities that companies need to think about. So what we have in front of us here is a very interesting structure, right? You see, what we have here is that we need to be able to think in our minds how a circular economy, could allow us achieve this reduction in waste. And the key element is that you need to think about these three things: linking business models to technologies to capabilities. Linking business models to technologies to capabilities. A key technology, big data analytics. A key technology is machine-to-machine communication. Both of them will fit into the Internet of Things. So in that sense, what we will see in that sense is that we need to identify again, and again, what I'm saying here is that it doesn't really matter what we're thinking about in terms of the business model at this stage, because we can find a business model that fits. So the thing that I would like to mention here is that we can find a business model, a circular business model that fits what we want to achieve. When we think about manufacturing, can we design things in a way? So when we think about manufacturing, can we design things in a way where we can transform or remanufacture? That's linking one aspect. So if you're in the manufacturing business, think about remanufacturing. If you're in the manufacturing business, think about transformation. If you're in the manufacturing business, think about material reuse, repurpose. When we think about certain assets and goods, what can we think about from a circular perspective? Think about maintenance. Think about repair. Think about reuse. Think about sharing. And that same thing also applies to consumption. And the same thing basically will apply to the end of life with regards to a system in general. So what we have here is that a circular economy needs information about, you see, if you want to apply a remanufacturing transformation, you need some information about asset components. If you want to apply maintenance, reuse, sharing, saving, you need asset utilization and lifetime information. If you want to think about repair, recycle, you need information about the current condition of the asset. So you can see now that all of these things can be facilitated and enabled by the Internet of Things. The fact that we need information, that is where the Internet of Things can help us. The fact that we need data, that's where the Internet of Things can help us. So again, the idea is that, putting everything in context, identify what your industry is, what your sector is, what you're trying to achieve, and then identify which elements of a circular economy model is going to be more applicable to what you're trying to achieve. And then what are the needs for what you're trying to achieve and for which circular economy business model you're going to be doing? Are we thinking about asset components, asset utilization, current condition of the asset? That is where the Internet of Things will help us. How will they help us? Through sensors, through locations, and through communication. Remember these three elements. Sensors, we need them. Location, we need them. Communication, we need them. So the IoT sensors allow real-time measurements of assets conditions, characteristics, and literally help us impose some kind of a protocol to communicate with other assets. So intelligent assets are key to implementing the circular economy model. That's what I'm trying to say. Now, if I bring an example of sustainability in the telecommunication industry, we can see, for example, that, Telefonica, all of these companies in telecommunications, because some people may say, okay, well, why do you talk about manufacturing? Because it's not all about manufacturing. Well, here we go. IoT, telecommunication industry, does it have a role? Of course it does have a role in circularity. IoT, telecommunication, plays a very important role. Telefonica, Telestra, Verizon. Now, if you take all of these companies, basically these companies have been involved in waste management. If you take, for example, Telefonica, they developed a digital waste management system. Resource management, 75 million customers receive a paperless invoice. Suppliers choose products with lower environmental impact, some measurements, some information. We need some information about, how far a car is going. What is it emitting into the air? How much CO2 is being emitted? So all of these require some sensors and require some meters in order to calculate and come up with some kind of a quantified number in order to make decisions. So what we have here is that we have, in general, we have all of these companies, and please do feel, please do read more about them and how these companies have actually helped in the telecommunication industry. How the telecommunication industry has helped and can potentially help in issues relating to sustainability strategies, in issues relating to circular economy strategies, such as waste management, resource management, suppliers, customers, and so on and so forth. So all of these things are really very interesting and critical in that respect. So as a final point that I would like to say here is that what we have been talking about is basically we have been discussing, if we think that we want to achieve a circular economy, sorry, if we want to achieve a sustainability strategy requires that we identify what could enable that strategy. And a circular economy is identified as one key enabler. But then we need to ask the question further. What enables circularity? A lot of things can enable it. An Internet of Things and intelligent asset can play a critical role. The role of data, the role of information, the role of sensors, the role of communication, telecommunication, all of these things play a very important part. And I would like to emphasize, regardless of which industry that you're in, you can find a business model from a circular economy perspective that can be applied to your industry, to your sector, and in addition to that, so this is your webinar for tonight. I'll be very happy to take a few questions from you.
Thank you, Professor Soufani. There has been some discussion in the chat and also some questions that we've been selecting. Maybe to start with, there is a question from Malu who says that when it comes to analyzing and generating valuable insights out of big data and data lakes, are there any preferences on your side about which of the business intelligence tools to use?
Well, I think that's a very good question, Malu. Thank you very much for that. But the important thing is that we need to identify which business intelligence, which business intelligence thing that we're going to be using. You need to have parameters in your mind as an organization. You need to adopt a business model, adopt an intelligent business basically approach that will create economic viability. That's economically viable. That is not going to cost you more than the benefit that you're going to be generating. That is financially viable. That's going to create some value, basically. That's efficient, and that is productive. And then it meets the objective. So you have to decide as an organization which of these ones will fit you. One intelligent business model, an intelligent aspect would be applied better in banking, for example, as opposed to insurance, in manufacturing, in an industry, in a certain industrial aspect, as opposed to retail, or as opposed to a food or supermarket. So the company needs to be able to identify that. Yes, thank you.
Thanks, Professor. I'm going to combine a couple of questions that's come up. And the real theme here is, okay, technology is a good enabler, but how can we ensure that the way we use technology itself is sustainable and avoid negative consequences such as e-waste, energy consumption, data privacy issues, and so on? So how do we avoid these negative consequences?
Well, that's a very good question. I mean, that is where we need to be innovative. It's about innovation, innovation, innovation. It is about what we call circularity by design. When you're designing the technology, the design of the technology should involve some circular economy model. So you might say, well, okay, technology, but what kind of technology? We're dealing with data here. Now, if you are going to be, some people might say we're going to be using clouds, and clouds uses a lot of energy, and so on and so forth. The answer is yes, I totally agree. But what we need to really emphasize here is that everything has to be structured in a way right from the start, from the beginning, by design. We already have existing status quo, incumbent type of technologies, but we need to be able that when we introduce a new technology, when we introduce a new innovation, when we introduce a new approach, a new structure, that in itself is circular, and that's why we call it circular by design. Circular by design. For example, we think about the chips right now. We want to get, say, for example, you want a new car right now. It's very difficult to buy a new car. Why? Well, because a lot of the car manufacturers want a little chip with semiconductors that exist in that chip. Well, that's technology. Yes. Why can't we get it? Well, there's a shortage of material. There's a shortage of this. Fantastic. Why can't we use old chips for these chips to be repurposed, remanufactured. I'm not a scientist, I'm not an engineer, but we need to think along these lines. Why don't we, there's a lot of e-waste that is out there. And all of these electronic waste, they have chips. Why is it that we don't get them? Well, we're going to say, well, it's going to be very costly to do that. But when we do it on a large scale, that is an issue. Now, but can we as an individual company do that? Well, it might be very costly, but can we as an industry collaborate to do that? That might be feasible. So technology is important, but technology should not be considered as a curse. It should be considered as a cure to some of the challenges that we have. If we design technology correctly, any technological design, industrial engineers, technologists, we need to think about how can we get this technology to be circular or to enable circularity. That's the idea. And that is the responsibility of not economists, that is the responsibility of scientists. A circular economy, yes, is about business models, about economics and so on and so forth, but it is a responsibility of scientists to get that message and say, this is what we're going to be developing.
Thank you, Professor. Another question from Stephen. It's if you think the pandemic has influenced the supply chains going forward, and maybe the experience of the blockage has, let's say, lead the creation of reservoirs of raw materials or even partially created or final products in a different way.
Well, supply chains, yes, I think there is a problem with the supply chain. And I've written a paper, probably you've read it recently in the Harvard Business Review on sustainable supply chains and whether these sustainable supply chain can be implemented. Unfortunately, sustainable supply chains are rare. So should we go back to some kind of a reservoir? Well, you know what? Probably it is one option that needs to be considered, yes. Provided that if we go to this type of approach, that, the reservoir will be there to serve probably multiple industries or multiple firms within an industry in order to make it economically viable. Because we even going back to just-in-time delivery is great, it's efficient, and that's what we need because you can reduce costs. But if the supply chain is interrupted, then the just-in-time delivery is not going to be working effectively and efficiently. And then your cost is going to go up. So can we say now that the disruption in supply chain is a one-off, or is it going to be expected to be this case moving forward in the future? Well, I hope not. I hope we're going to have a smooth supply chain moving forward. But we need to have a plan B. And we need to be prepared for what we call the extreme events. Some people might say, well, we have an interruption in supply chain because of COVID. Hopefully, hopefully that we are moving out of this. We will be next year. But what about if something else happened? So my approach to this, if we go back to the old approach of reservoir material, reservoir of components, as opposed to have a just-in-time type of supply chain, just because we have that risk of being interrupted, then we need to think about the cost and benefits in there. I'm not saying one or the other. I'm not going to say, well, this would be the better one or that. I'm interested in what's the cost and benefit associated with that.
Thanks, Professor. Another question related to policy. You mentioned, for example, the right to repair. So there's two parts to this question. The first part is, to what extent do you think past policy or lack of policy has led to the problems we face in low circularity? And the second aspect is, what do you think policy needs to do to enable more circularity in our society?
Yes, of course. Very good. Thank you very much for that. I mean, policy has an impact, yes, either positive or negative on circularity. We've seen that. And so it could be, yes, we need and we do need a good policy, but policy should be designed to incentivize circularity, not to punish people who don't go circular, not to impose penalty. I mean, I believe in incentives. As an economist, we believe in incentives. Any kind of policy should be designed to incentivize. But in addition to that, any kind of policy should be designed to be comprehensive, and it covers multiple areas within the economy. Any kind of policy should be simple, accessible. Any kind of policy should create less bureaucracy, not more bureaucracy. So that is what we need in a policy in order to have a successful circular economy model.
Thank you, Professor. We have still 5 minutes, so I wonder if, since there is a question about it, if you could maybe elaborate a bit more on the impact and application of 3D printing as an enabler, and maybe provide some examples.
Yes, I mean, like a very important example, very interesting example. Basically, 3D printing is an enabler. There's no question about that. Additive manufacturing is what we're doing here is that if you are in location A and someone else is in location B, but we have the same material, then the same material would mean, let's say, for example, plastic. You take the plastic, you crush it, you turn them into basically powder, and then you have the 3D printer on the other side, and it will produce, as long as you have the same material, you'll be in a good position to produce the same device, the same part, whatever the case might be. And in essence, what happens 3D printing is that you're reducing the shipment expense. You're reducing shipping things over from one part to another part. But in addition to that, with 3D printing is that you can use in the 3D printer some standardized material that you could have thrown them away, namely plastic. So plastic could be used in additive manufacturing to produce, to produce some basic products that you need, to produce some furniture that you have, to produce even a whole range of other things. Now, 3D printing can exist in different industries. It can exist, basically, if say, for example, if you're a car manufacturer and you have sold the cars in different parts of the world, now the question that we need to ask ourselves is that if one of the key, but not necessarily key, basically component of that engine, goes faulty, do I have to wait for the supplier to send me the component or the device or basically the part if it is not available? Or can I, using a 3D printer, assuming that I have the material as in the original part, can we take that original part, for example, and can we crush the original part into the sand for a 3D printer and then remake it, reconstruct it using 3D printer? That's an example. So yes, a 3D printing approach is a very important approach. Okay. So this is, I hope this has been useful for everyone, and I hope I've addressed some of your questions in general. I really hope that, that you find this module insightful, applicable, useful to whichever industry that you're in. And I really wish you all the best in whatever you're doing. And yes, we need to be positive about building a better world in terms of, we can't just say it's not going to be done. We can't regret not trying. We need to be really able to understand all of these things. So it's been a pleasure sharing with you some of the things that I know about circularity and basically what we know about sustainability. So in this note, I would like to thank you all for being patient and basically listening to me. And I would like to thank Sam and Fran for their great support, as well as the program support that are always there to help all of us. So thank you very much, and I wish you all the best. Thank you very much. Bye-bye.